Hi folks, today we're going to be doing some basic strength testing on the 3D Lab print Spitfire model's left wing that I printed a few days ago. I wasn't completely happy with my print settings on this first attempt at printing the wing in PETG filament. So I figured why not use this wing to do some basic testing to see how strong the filament and the wing design itself is. My name is Tiaan and welcome to 3D Printing for Drones. A few weeks ago I bought the 3D Lab Print RC Spitfire model and I'm finally getting around to printing the aircraft. This is a pure RC model and of course not a fully fledged UAS, but once I've had a look at the fully printed aircraft and have sent it off to Gary to fly for a bit, I can start modifying the design to be more than just an RC aircraft. I love a challenge, so I'm attempting to print the aircraft in PETG filament, even though 3D Lab Print recommend printing their models in PLA. PLA doesn't warp, so it's much easier to print larger objects with thinner walls. But since the aircraft will be flying under the African sun, I decided to skip PLA and go straight to PETG just in case. PETG is supposed to have low warping as well as have better impact resistance and heat tolerance than PLA. So last week I got in some new PETG filament to try out from Filament Factory in Johannesburg. It's a fluorescent orange actually and looks quite nice in person, but unfortunately the camera turns it a bit towards the salmon color side. I started with the left wing of the Spitfire. 3D Lab Print split the model into sections to allow for printing on home printers that have smaller build sizes than industrial ones for example. The first 2mm of each wing section is printed with 2 outside walls and then a single wall upwards from there. The main reason I wasn't happy with my print settings is the bulging that happened in the first few single wall layers of each wing section. The first 2mm did contract slightly as it cooled, and I think this is partly what caused the bulging of the layers above that. Another part of it could be that I had my bed temperature set a bit too high at 90 degrees Celsius, which might have kept the first few single wall layers a bit too soft throughout the 19-hour print. And then the weight of the rest of the wing was probably a bit too much for these softer layers. I printed the wing at a maximum speed of 45mm per second, relatively slow compared to what I normally print at, but I didn't want to take a chance with any failures in a big print like this left wing. To assemble the wing I used medium CA or superglue with a CA activator spray as recommended by 3D Lab Print. This does a surprisingly good job of keeping the sections together, with the wing tending to break around the bond instead of at the bond. Alright, so now that we've got it stuck, we've left it about 10 minutes. With the kicker, it's not going to get any better than it is right now in terms of the bond with the cyanoacrylate. So yeah, important thing, obviously I'm going to be using my safety glasses for this because PETG doesn't really break too easily, but when it does tend to shatter, so I don't want any pieces flying into my eyes. Okay, we're going to start just testing the skin here, the other weak spot that I'm going to keep. There we go. See the wing is, there we go. Let's see there. But it's still already. It's pretty strong. Still the soft bits. But in terms of aerodynamic force, this thing is not going to. It's not going to go anywhere. There's enough flex in the wing. So torsionally, you can see there's quite a bit of flex. There we go. See? didn't break at the bond, broke out there. I'll take that one apart. Let's try and break that bond. Alright, so here didn't break, there did break somewhat at the bond. Broke. Didn't break there. Let's try. That's not going to break. So overall, the wing design seems quite strong, and I'm happy to print the rest of the plane now. I think rough field landings will be interesting though, so we will see. We also want to see how practical the whole process will be, with repairs and printing replacement parts with all the various aircraft sections being superglued together, instead of slotting into each other mechanically. So in this case, letting the aircraft get damaged out in the field is actually a good thing. Keep an eye out over the coming weeks as we continue with the Spitfire print. Thanks for watching, and don't forget to hit the subscribe button and the little bell next to it so that you don't miss out whenever we release new videos on Drone and Sundry.